Engineering 305, Chapter 1, Review of Statics. This is just a quick overview of statics. This is what you just finished probably in the spring or the year before. For some of you, I suppose you might have taken it a full year ago in Germany. And so this may be really necessary, but there's half dozen homework problems to help you figure it out too. But this is the quick review of statics from Chapter 1 of Riley. This has some pertinent equations from the study guide that we want to know, and that is some of the forces are equal to zero and some of the moments are equal to zero. Should not be surprising. The goals, the course learning objectives that are met in this section is that these are really not new things we're learning. This is from the header. Prior to taking the class, the students expected to be able to apply those two equations within a fixed or moving reference frame to a rigid body. Demonstrate understanding of two force members by solving systems which are assembled from two force members, so solving a truss structure. And then you've got to be able to apply trig. You've got to be able to apply trig to calculate, is it a sine, is it a cosine, is it a tangent? You've got to be able to use your trig functions. So those are our pertinent equations and our pertinent course learning objectives. So statics, I'm only going to think about statics because if you think of statics, you can do dynamics. All we have is this extra acceleration term. We're not focusing on that. You should have that solid. So we're just looking at the static side of it. So what types of forces do we need to consider as we're looking at statics? And we typically break that up into two different categories. We have body forces, and body forces consist of things like gravity. They act at every particle. They act on every molecule that makes up that body. Magnetism and heat generation are also body forces. Magnetism would pull on all of the body. Heat generation is not a force typically that goes to motion. But heat generation may show up later in the course as we do some thermal problems that then affect some of the other stuff. So it is a body force of types, especially if you get into the finite element. I wanted to include it for that reason. There are also surface forces, forces that act on the surface of a body. And these are the places where we spend most of our time. And they get looked at by how they are applied, whether they are applied at a point or whether they get distributed, and whether they're pushing on more of the whole surface or whether they get just on that point. Distributed loads may also look like pressures. So there are other things to consider, and those might be the internal forces. That is, if I'm pulling on my finger, and then if I cut my finger at the joint, there would be some force pulling the fingertip that way and pulling the rest. Yeah, we have those internal forces, and we talk about reaction forces. Reaction forces are really just what's on the next body. So we have to have that nomenclature potentially somewhat clear so that we understand what we're dealing with. So that's it. That is our quick review of statics and dynamics. The next video that you've got to watch is going to be solving an example problem, a truss problem with a car on a bridge, and I hope you enjoy that one also.